Hello and welcome to today's Leetcode challenge. Let's begin our question. Okay, question 101, symmetric tree. Given the root of a binary tree, check whether it is a mirror of itself, i.e. symmetric, around its center. Okay, so I remember solving a question very similar to this. It was to compare if the trees are identical. Here we could essentially be doing the same thing, comparing that the trees are identical, except on one iteration we're going to be doing left parent or left current right, and the other one we're going to run through right current left. And that should do it for us. What am thinking of though is how do we do this in one function? So meaning that we have a definition of a symmetry function that takes in a left node or a node that is going to be considered as the left current right and the other node as right current left. Let's define a symmetry function with a left current right. Let's just call it the left node and then the R node. And what are the conditions under which this tree will buckle? Well, first, if not L node and not R node, return true. These are, let me start with something else. This symmetry function will be returning true only if the two nodes that I'm being passed to are the same. Additionally, that the children of these L node and R node are the same. Let's start defining some characteristics that would make it the same. If L node, if not L node and not R node, return true. So that's the first condition. We have no more nodes, so meaning that we have reached either the leftmost for the left node or the rightmost for the right node. Then we should have another condition that if one of them is actually there and the other one isn't. So if not, so how would I define this? If not L node and R node, or not R node and L node, or L node and not R node. Would this even work for me? So basically I'm worrying here that one node exists while the other one doesn't. And you know, or could I just do this with if not L node or not R node. So I know that both of them, or not, I know that both of them are not false. If at least one of them is false, then I also return false. right? Because if at least one of them is false, that means that the other one is true, because not both of them are false. And then, what do I do here? I return... So now here's the situation. So L left current right is going to be the same with, let's say, outer symmetry is going to be outer, meaning going out that way. So for L node, it's going to be L node left, R node right. Outer symmetry is true. Oh, I guess let's compare that. If and then current sim is just L node val equals R node val, and then inner symmetry is going to be the symmetry of L node right, R node left. Return outer sim and cur sim and inner sim. What? Return sim of root. Okay. Of root. Okay, sweet. First try. Okay, actually one more quick condition. Left, right. This should be a little bit faster because we're skipping. How is this still not the fastest? Let's see. If. So I could completely not worry about, so like if does not equal return false. I could do that. Let's put this all into one. Or no, doesn't matter. And then we can just say we can stop worrying about this guy. And is this any faster? No, it's not faster. Yeah, why? I just feel like if I'm not similar, then just skip comparing. What if you could do like a global? What if on a false you could do like a complete exit of this recursion? How would that work? So that's why I'm thinking that maybe a non-recursive solution would be faster. If you're just building a set, sorry, not a set. If you're just building if you're doing this iteratively. Yeah, why was this faster? That's actually kind of freaking me out. Oh, this wasn't faster. This is the same. So they lied completely. Maybe this is one of the... We're going to take a look at the solution right soon, but if... Let's see. If not, then return false. I'm omitting this guy completely, and we can even say something like this. This and see, is this better? 82. Okay, for all intents and purposes, this is probably the most correct solution. Let's see who does it better. Who does it better by almost twice as fast. Yeah, this is not like this is not a super hard problem, so I don't see why there would be too many comparisons. So they're using the is none. Let's just honestly try that. What if so if is none, so maybe that operation is just faster. Is none is not none, or is not none. None. Say what? If L node is none and R node is none, return true. If L node is not none, is none. Or is none, sorry. Nope, nothing. And this is one-to-one code. So yeah, I would just stick to what is it, the solution that we had. Yeah, just use this. Very simple. I don't know if there's a better approach. At least speaking from a point of like making sense. Anyway, thank you for watching. See you later. Bye.